Algebra 3, Chapter 1, Section 3, Modeling with Linear Equations. Mathematical modeling is the process of translating a real-life or word problem into an algebraic expression or equation. So this is kind of like translating a foreign language, so there's a few key words that you need to be aware of. An equal sign can be expressed by the words equals, equal to, will be, is, are, was, or represents. The words that will clue you into an addition symbol will be sum, plus, increased by, more than, or total of. A minus sign could be represented by the words difference, minus, less than, subtracted from, decreased by, or reduced by. Multiplication can be identified by the words product, multiplied by, twice, times, like 3 times or 4 times, percent of or fraction of. And you know you're dividing when you see the words quotient, divided by, ratio, or per. So let's try this example. You need to write a verbal description, that means use words, for the algebraic expression without using the variable. In other words, you can't say z plus 10 divided by 7. Give this a try, pause the recording, and resume the recording to check your answer. A number increased by 10 is divided by 7. We did not use the name of the variable. We indicated that it needs to have 10 added to it first, and then that the division is second. Now that you've seen one, try this one. Pause the recording to give it a try, resume the recording to check your answer. There are different ways to express this. The important thing is that you need to indicate somehow that the variable must be added to 2 before being multiplied. Here it says -3 is multiplied by a number increased by 2. You could say that a number is increased by 2 and then multiplied by -3. Again, there's different ways of expressing it, but you need to somehow convey the proper order. Now we're going to do the reverse. They're giving you a verbal description. You're going to write the algebraic expression. Pause the recording, give this a try, resume the recording to check your answer. Okay, the distance traveled in t hours by a car traveling at 55 miles per hour. Distance equals rate times time, so the distance will be 55t. Try this one. Pause the recording to give it a try and resume the recording to check your answer. Again, it's a distance problem. Distance equals rate times time, but this time we actually want time to be on the left side of the equal sign, so we solve for time, and we get that time is distance over rate. The distance is 900, and the rate is r. Okay, we're going to work on solving some problems. I broke outlines a procedure for that. What it suggests is that we first rewrite the problem with a brief verbal description. In other words, pare it down to fewer words. Then we're going to translate this to a verbal model. This is words combined with operation symbols. And then finally, translate the verbal model into an algebraic equation and solve. I would also encourage you to make sketches of the situation when that is appropriate. Now try this. Write a mathematical model for the problem and solve it. The sum of 3 consecutive natural numbers is 804. Find the numbers. Pause the recording, give this a try, and resume the recording to check your answer. Okay, 3 consecutive natural numbers, that means no zero, no negatives, no fractions, can be represented by n plus 1, and n plus 2. Because if you think about it, pick any number to start with. To get to the next, you add 1, and then to get to the third one, you add 1 more. So in other words, you've added 2 from the number you started with. The nice thing about these problems is they all tend to follow this pattern. So if you can get the pattern down, you can really do these very easily. So we're going to add n plus n plus 1 plus n plus 2 for a total of 804. That was the hard part. Now combine like terms and divide. We get that n is 267. Our other two numbers are 268 and 269. Now try this one. Read carefully, write down what it's saying, solve the problem. Pause the recording to do this and resume it to check your answer. Okay, we're going to let our two numbers be x and y. So y equals 5x. We also know the difference between them is 148. And since y is bigger, because you have to multiply x by 5 to get y, we're going to say y minus x equals 148. Now we're going to do a little substitution. Since y equals 5x, we'll replace y with 5x. 5x minus x is 4x. Divide to find x, and then don't forget to go back and find y. Here's another example to try. Pause the recording, give it a try, and resume the recording to check your answer. Again, we're going to let the two different amounts be represented by x and y. We have two different relationships between them. We know that y is 15% less than x, so y equals x minus 0.15x, which gives us 0.85x. We also know that when you add them together, you get 1,125. As with the previous problem, we're going to substitute. Since we know that y is 0.85x, we'll replace y with 0.85x. Combine like terms and divide. For x, we get $608.11. Notice we're rounding to the hundreds place, as you should always do when your answer involves money. Multiply that by 0.85 to solve for y. Now try this problem. Pause the recording, give it a try, and resume the recording to check your answer. Okay, again, x is going to be our original price. The sale price is the original minus the discount, so it's going to be x minus 0.165x, and that equals $1,210.75. Combine like terms and divide to find that x is $1,450. Literal equations. A literal equation contains more than one variable, and anytime you've used a formula, you're using a literal equation. All those geometry formulas you used, for the most part, those were literal equations. In your book, you can find common formulas from geometry, science, and finance on page 95, so if you need to use those as a reference, please do so. I will not expect you to have a formula memorized on a test or quiz unless I have already let you know that that is something that's important that you need to have memorized. So unless I have said that it's something you need to know, I will give you the formulas that you need to use. Sometimes with literal equations, you want to solve for a given variable. For example, you might want to change a equals pi r squared, the formula for the area of a circle, to r equals the square root of a over pi, which is the formula for the radius of a circle if you know the area. All right, let's try this example. We're dealing with perimeter. Remember, the perimeter is the distance around an object. Give this a try, pause the recording, and resume the recording to check your answer. Okay, first it suggests that we should draw a diagram. Always a good idea with problems like this. And we represent the width with a W and the height with an H. We use the information to write the height in terms of the width. The height is 2/3 the width. We write our formula for perimeter, and again we substitute place of H 2/3 W. And we work the problem. Combine like terms, solve for W, 0.9 meters, and then solve for the height. Here's another example. Give this a try, think it through, pause the recording to attempt it, resume the recording to see how you did. You have 4 tests. The first 3 are worth 100 and the fourth is 200. That makes a total of 500 points available for all 4 tests. We want an average of 90%. 90% of 500 is 450. So you know that you need to get a total of 450 points. You also know that you already have an 87, a 92, and an 84. Add those together, that gives you 263. Subtract that from 450, and that tells you that you need to make 187 points out of 200 on the final test. Here's another problem. May look familiar. You probably did a few of these in geometry. Give it a try. Pause the recording. Resume the recording to check your answer. Okay, we have an old similar triangle problem here. We have the height of the flagpole that we don't know, the height of the person that we do know, and then we have some measurements for shadows. We're going to use the fact that since we have similar triangles, the 5 over 35, which is the length of the bottom side of the small triangle over the length of the larger triangle, equals 6 over h, the height of the person over the height of the flagpole. Cross multiply and find that the height of the flagpole is 42 feet. Try this investment problem. Pause the recording, give it a try, and resume the recording to check your answer. We're going to let X be the amount of money that you spend on dogwoods and Y be the amount for maples. The total inventory is X plus Y, which is $40,000, so $40,000 total. The profit for dogwoods will be 0.25X, and the profit for maples 0.17Y. The total profit is 20% of $40,000, which is $8,000. Now we're going to put together two equations. 0.25x plus 0.17y equals 8,000, and x plus y equals 40,000. Probably the easiest way to solve this is to solve for y and then substitute. You can see the process there. We find out that x is 15,000, while y is 25,000.